I mean, what the what is this?
We're a mining network, the peer-to-peer system where the computers are expending computational energy and power to produce something which is valuable. Instead of hashes, we're mining the intelligence element. And then there's validation of that element based on a set of validators. By focusing on the market, we can create a sort of network of computers which are all working together in producing this neural element.
The largest thing is the combination of all of the other things.
AI is going to become a common platform, a platform on top of which a whole ecosystem can be built.
And when you're working with abstract markets, you can consume resources that others can't. The largest supercomputer in the world right now in terms of hashes, bigger than any government, is Bitcoin. Why? Because it's protocol-based, because it's permissionless, because it's incentivized, because it's the combination of a variety of people across the globe. We have the trajectory to create something bigger. I think it's really just a matter of time.
Some basic values have to be preserved.
And so it favors us to have open platform. This is the best way to make progress as fast as we can.
To build a healthy symbiosis with this really powerful technology.
It's exciting because Microsoft doesn't own it, and therefore there's a tremendous amount of innovation happening.
And then the open source platforms won because they are more secure, easier to customize, safer. There's all kinds of advantages.
I don't think there's anything more important than open source decentralized AI.
The largest thing is the combination of all of the other things. There's been many failures in this. OpenAI failed, really. They wanted to do that. They wanted to create open AI, but now they're closed AI. And it's because they didn't have the technological substrate to do it.
Because we don't have enough GPUs.
Me augmented with the Bittensor prompting network when I'm doing my code, I can write it 10 to 100 times faster. I become a 1000x engineer with this technology. And so the amount of work that I can get done is so much better. It's so much faster. And as a result, that if time is equal to money, and I'm saving time, I'm saving money.
This is awful. Seriously, it doesn't even have, it just has a rotating thing on here.
Good morning, everyone. Thank you everyone for coming out at this time, 10 o'clock. I'm here to talk to you about Bittensor, quite a challenge to explain this pioneering, incentivized, decentralized machine learning network, or machine intelligence network, in 18 to 20 minutes, and then still give you a little bit of time to ask some questions. It's a rabbit hole when you go down it, but that's what I'm going to attempt to do, and I'll be around afterwards if anyone has any other deeper learning questions that they want to ask. So I'm going to get in quite quickly with some origins, some brief origins and history, because the real thing I want to explain is the current landscape of Bittensor, where we find ourselves now, and people may have seen or heard about it over the last year or so, but I find the advancements over even the last month already put us in a place that could be very interesting to, obviously, Urbit developers and anyone wishing to utilize this technology. So, a little bit about the history. You would have seen from some of the sound bites. It was created by Jacob Steves and Ala Shabana, two researchers at 4AI, which is obviously now Cohere, who were independently working on the same idea, and they came together, and this idea has its roots in Bitcoin, and a lot of the tokenomics of the incentivization layer of Bittensor have throwbacks to Bitcoin. But what they were looking at was the computational power of this enormous network, and how something like this could be used and applied to their field, which obviously was GPU compute and the production and the market for intelligence. So what is Bittensor? This is the question. It's I see it as a multi-layer network, and this is one of the important things to understand. The data layer, this primary data layer, is all about the generation of intelligence, or now also resources. But then underneath that, you have an incentivization layer, which is a blockchain-based layer. Because one of the questions we often get is, what is the limitation of your network? What's your throughput? What about blockchain issues? What's your TPS? These are very separated layers. The power of the data layer is infinitely scalable based on the resources of its participants. Whereas the incentivization layer is purely responsible for recording the value, the incentivization landscape, or the incentive landscape of the ecosystem. And then the jam in that sandwich, so to speak, is a consensus mechanism, UMA consensus. I'm going to talk a little bit more about that later, but it's essentially a consensus mechanism that assigns a value and enforces an agreement between the participants of the network to assign value to that data, to those resources. At a fundamental level, that's what we've got. Who uses this? Who are the participants? Obviously, you have users. From end users, consumers, developers, business, anyone that wants to access this network are fundamentally the users. And the network itself, the network is actually a network of networks. Each network within the Bittensor network is now called a subnet. And it's an individual instance of the Bittensor network controlled by a root subnet. Now, the root subnet is very interesting. It's like a market of markets. It decides, or helps the users of the network decide the value of the different subnets or commodity markets within the Bittensor network. So I've got a diagram for this, but I just thought I'd go through this first. Each network is made up of miners and validators. Miners produce intelligence, resources, compute, and the validators assess the value of this intelligence and assign it a value, which then helps the miners understand the value of what they're doing and naturally evolve. So any user must go through a validator. A validator is like a gateway to the network. And this is one of these very important concepts, because what this does is it promotes a relationship of trust between validators and miners. It adds layers of security in that the network cannot be abused by external forces. And how a validator queries a miner, and this is a very abstract concept. Actually, the subnets themselves can be now designed in a way that suits the developer of a subnet, but the abstract concept remains the same. As a validator, you query a miner. You ask it a bunch of questions. I come into a room, I'm the validator, you are the miners, and I ask you a question, or I ask you for a proof of resource that you are supplying, and you give me back your answer, your answers, your collective answers, and I can assess and score those answers with the UMA consensus, and then I can rank you. And I can ascertain and give you a hierarchical list and scores to which, obviously, you are then incentivized and rewarded. And based on your responses, I can then pass those responses to the user, to the incentivization layer, so you get your reward, and then you, as miners, and this is a visualization site, I'll come to visualization, can visualize this and use these results in order to improve what it is that you're doing, you're offering to the network. So the incentivization layer, very briefly, it uses the native token of Bittensor, which is TAO, and the miners and validators, as I said, are rewarded in this token for performing tasks within the network. And it is a substrate-based blockchain, and I'm happy to go into further details on that, but in itself, this is a visualization of it that we might look at on a day-to-day basis. This is actually a site called, or an element of a site called TAO Stats, and this is what a miner might look at. To say, I know it's just a bunch of numbers, but what this enables you to do is to see how you're performing against other people, your value, how you're being rewarded, how others are being rewarded. And in an incentivized network, what this does is it strives for betterment and improvement, natural, Darwinistic improvement of the network. Miners lose their position on the network, new miners come in, and it becomes a highly competitive environment with which the network and the resources supplied by the network improve. How is this all worked out? This is one of the magic of the Bittensor ecosystem or network is the UMA consensus. It's an agreement on the quality and the value of the intelligence or resources being produced. Now, this is actually quite interesting because this transforms incentive into what I would call an incentive landscape, a way of assessing the overall value of a subnet, so a commodity market within the Bittensor network. And what this does is it strives towards the betterment, naturally towards the betterment of the network. The participants, it is within everyone's interest to better the resources, to better the answers. If I was to ask you all a question and you were to give me back an answer, and I would throw out the 3 people that gave the answers that we all decided were of the least value and invite in some new participants, the collective intelligence of this room would increase in value. Assuming we have people outside who still want to come in. If we were incentivizing them to come in, we're highly likely that this room would fill up with participants very quickly. The beauty is, it is also agnostic to data types. Being designed originally around language models, inference, one of the harder things to measure, it has a kind of a fuzzy consensus which allows it to be applied to many different data types, but also allows it to be applied very simply to binary data types, whether you are providing a yes or a no, a right answer or a wrong answer. So as you'll learn in a minute when I talk about some of the data types that are on the Bittensor network, it's incredibly flexible to any kind of utilization or deployment of these subnets. So where are we now? And I think this is the most important thing, because we could go back and I could spend another presentation talking about how we got to where we are. There's been many iterations of the Bittensor network, many points that I would consider to be proofs of concept from which the next stage picks up. We are currently at a release of Bittensor called Revolution. And what this enables is any participant on the network to deploy a subnet. The slots are currently limited to 32 slots, and as the last one fills up, the person or the slot with the subnet with the least value is kicked out. This has been live for 3.5 weeks now. We have 4 active subnets. We have 16 subnets under development. We have over 6,000 active mining slots available for participants of these active subnets. And these subnets, the live ones, include text generation, image prompt generation, audio, data scraping, and this is where it gets very exciting, storage, file storage, machine translation, prediction-based subnet, pre-training, MapReduce, pure multimodality. And these are just the ones that have been registered in the last 3 weeks. And my personal belief is that we're currently looking at a phase 1, a wave 1 of subnets where people are coming with these abstract ideas and proven theories. You know, it's a language or it's a machine intelligence-based network. So, of course, we want text prompting on there. Of course, we're going to get image generation. I'm sure video is going to pop up soon. The first things we think about when we think about distributed compute, a render network, file storage. But soon what will come as these sort of initial ideas come forward will be a second wave of people looking at things and saying, that's very interesting, but have you thought about this? And I'm very, very excited about this. And developers, they access the network through either simplistic API keys or directly onto the network infrastructure. Again, to get too deep into that at this stage will not give me enough time to talk to you afterwards, but I will show you the basic developer access through an API key. Building onto the network requires building through a validator or having direct contact with a validator, because these validators provide this gateway to the network. But it's the community driving development, and that's a really important thing. The Open Tensor Foundation, who oversee the development of the core Bittensor protocol, are allowing the natural decentralization of a network. Obviously, any decentralized network must have a centralized driving force to start with, and normally what happens is there's a slow fade and step back, and this is happening. This is what's happening at the moment, in that the community are driving the development. And the community don't always want to go the same direction in terms of how reward mechanisms are defined as those who have come before. And the beauty of the network is it is allowing this to happen. It is essentially free market economics in its purest form. Value proposition through the assignment of incentive. If we like what you're doing, if the network participants like and value what you are doing, you will succeed as a miner, as a validator, as a provider of intelligence. Just some basic UI as to what you might look at now if you wanted to access the network. Anyone can go and grab an API key. They're free, because the incentivization structure of the network currently is promoting this community-driven or this development-driven initiative where the network is incentivized. So through that incentivization, we can, and the fact that the miners are being rewarded, the validators are being rewarded, those that want to come and build and develop on this network are not having to pay to play, so to speak. So you can go on and you can grab a free API key. Now these are API keys that you can instantly use for image and text today. You can do it, as you're sitting here. You can't get this with an OpenAI key. You can't go and get this with a stability key. Yes, you can link together a number of different keys, but this, within the next month or so, will allow audio, will allow you to store your files, will allow a plethora of different access all through singular API keys. I mean, an interface is easy to sign up. You can code it in any language. It is language agnostic. The core elements of Bittensor, whilst coded in Python, can be utilized with fast API. So if you want to build something in your specific language format, you can. You can build chat apps. I mean, we all know what a chat app looks like, but you can just whack out a free chat app. This is just a forked open source repository with an API key plugged in, utilizing the Bittensor network. You can do the same for image generation. It's Stable Studio. It's the open source version of Dream Studio. Plug in an API key to the Bittensor image network, and you have a fully functioning, free, online image studio right now. It's there. You can go and use it. And enjoy. So where does this take us into the future? As I think I've mentioned a few times going through this, we have the creation of interconnected commodity markets. This is what's being created, and they are programmable by their creators. The incentive structure can be defined and programmed by those that are creating them. And what this does is it leverages this huge, connected, decentralized computing power, and we're producing intelligence at a massive scale. And the potential is only restricted by the throughput being generated by the participants of the network. So essentially, we are creating this incredibly powerful network that's not just in the hands of the few, but open to everybody. And so we're building together. And developers can program these markets, as I've mentioned, but I've got to say it again, because for me it's one of the most powerful aspects of the network. It is not just limited to intelligence, storage, compute, all utilizing these dynamics of decentralized marketplace. And as I've said again in the slides, because I was excited about getting to this point, it's free. The current landscape allows developers to deploy without cost. Once we look further into the network, into the future, there will become a point where validators must produce revenue-generating business models, but in its current incentivized state, following the tokenomics of Bitcoin, 21 million tokens, 10.5 at the first halvening. The next halvening is October 2025. It's a slow path to needing for people building on a network needing to generate revenue. So at the moment, it's a very open network that is solely driven towards advancement and development of the infrastructure within it. And this gives it this ability to become this hugely powerful computer system, a shared supercluster not owned by any single entity, for anyone that wants to profit from it. Where are we going? Waves and waves of innovation. We can keep up with new innovation within the AI ecosystem, machine learning ecosystems, with any aspect of advancements of compute, if they use and can benefit from a decentralized, compute-driven network. It can be plugged into Bittensor. It can advance with Bittensor. All of these emerging intelligence types. Soon there will be smart contracts, and this is something I almost don't want to get too deep into, the potential of what happens when you plug smart contracts into a incentive system, how you can redesign a reward and incentive system based on the utilization of smart contracts. You can give me your answer to the questions I've asked you. I don't have to judge your answer now. I can judge it in the future and then reward you accordingly. And this, to me, is one of the things that I'm most excited about with the future of this network. got it bang on the minute. I'll give you 10 minutes of questions and answers. So hopefully, if anyone has any questions, I think they have a microphone to pass around. By all means. Otherwise, I'll just keep talking. Any questions at all? I wasn't prepared for this part. There we go.
Can you hear me?
I can indeed.
Okay, so I wanted to know if the validators are agnostic to the subnets. So do you have a specific set of validators that can validate any subnet, or each subnet needs to onboard their own validators?
So the validator landscape is actually a very interesting one. Currently, validators exist across the entire network, but it is their choice. They have two choices. One, whether to be present on a subnetwork, and secondly, whether to value that subnetwork. Within the root subnet, the validators can vote as to which subnets have value by assigning them emissions. It's a dynamic, fluid system. I can give you emissions today and take them away tomorrow. So I can choose the subnets that I value, and I can also choose the subnets that I wish to be present on. So if a unique case, a business case scenario, wanted to deploy their own subnet, there is a potential that if they were not trying to attract delegation from the overall network users, they could be present on a single network or subnetwork and just utilize their time and resources for that, and no, they wouldn't have to be present on other subnetworks. The validators themselves, they deploy, for each subnet you would deploy on usually a different machine. Some require higher GPU load, some of them you can validate on CPU. Usually as a validator you separate your validator machines. And so yeah, you can decide, and you run different code. The subnet creators would obviously have different repos for each subnet. There is an existing subnet template that exists on the Bittensor GitHub that I have linked at the end. And you can build your subnet based on that, a very simplistic subnet based on what has come before. But there are also people building subnets from the ground up. I know the current prediction subnet is from the ground up. Some people are actually starting to turn the rewards landscape itself on its head completely because they have a better idea as to how things should be done. And so you would, as a validator, deploy that code, all open source, of course. And yeah, I hope that answers the question. I can go back again and talk about some of the other points that I skirted over because I was running out of time. Any other questions? Right, the silence then. Should we go back? I think one of the things that's always interested me with this network is understanding, I think, the economic side and the ability for it to really provide developers with this ability to create applications that touch end consumers. One of the things that I've been talking about with people that I've touched base with here with Urbit, and I touched on it yesterday in my talk, was very often we build these ideologies very much around a technology-based background. We're all quite tech-orientated, and we have solutions that work for tech. But what this network, whilst being incredibly technical at the moment in terms of getting to grips with it and understanding the concepts, it also provides, through validator services, a very simplistic way for anyone to get involved with it. Many years ago, I taught very basic web development at university, and I feel that I could go back to that stage and be teaching 17, 18, 19-year-olds how to program with AI using very basic sort of JavaScript techniques. I'll come back to where we were here. Just going into a classroom, showing someone how to download or to create an API key, letting them choose whatever language we might be covering, and build basic apps in 5 minutes. In fact, you can even use the app to build an app. We have systems within Bittensor recently that have been built on utilizing the chat interface. We have a meme token where they programmed a smart contract using the API, the Bit API text chat interface. So this, for me, is incredibly powerful, and one of the things I want to leave you with, As someone who doesn't have a huge amount of experience in Urbit itself and the potentials, so I don't feel I'm in a position to tell you how to integrate something like a decentralized compute network with Urbit. But what I would hope is that I leave you with possibilities, ideas, a little seed of imagination planted as to how Urbit might utilize access to a network like this. The self-sovereign identity and data that you hold within an Urbit, within your Urbit instance, the power and potential of being able to connect and send out and receive back through a decentralized network. Unless there's any other questions, I'm going to leave it there. Thank you.